Okay, students, so this week we are going to do some word problems, like applications for trig functions, okay? So trig, trigonometry. So applications just meaning word problems, basically, like real life applications. So let's look at some. The number one thing we have to do with these is actually do like a little diagram that will help us know which side or angle we're looking for. The first thing we're gonna remember is our SOHCAHTOA, right? So which is sine and then opposite over hypotenuse. Cosine is adjacent side over hypotenuse. And then tangent, which is opposite over adjacent. So we remember our ratios here. And then remember that for our angles, we're going to be using the inverse functions and of sine, cosine, and tangent in your calculator. So that's basically mostly for your calculator. All right, let's do some diagrams here. So to see which side we're looking for. So it says a ladder is leaning against the side of a house that forms a 65-degree angle with the ground. The foot of the ladder is 8 feet from the house. Find the length of the ladder. So we're looking at, this is the house, right? And then we are looking, this is the ladder, right? Let's see, something like that. I don't know, whatever. And then we have a 60-foot 65 feet angle with the ground. So it's forming this angle at 65 degrees, okay? And then it says that the foot of the ladder is 8 foot from the house, which is right here, 8 feet. So this, from the foot of the ladder to the house, it's 8 feet. And we're looking to know what is the length of the ladder. So we're looking for this one. So now we know we are looking for cosine. That's the one we're using because we don't have anything on the opposite side. We're looking for the hypotenuse and we have the adjacent side. So it's cosine. So let's do that. So cosine of the angle equals, and what do we have? Adjacent over hypotenuse. So that's 8 over x. And then we know we're dividing because the x is below here. So we're dividing 8 divided by cosine of 65. So let's do that. I use my calculator here. So that's 8 divided by 65 cosine. And then press equal, it's 18.9. So 18.9. So x equals 18.9. Now remember, we're dividing, right? Forgot to write this. I always write it. Okay, that's how you do this. So we basically don't remember. Like the one thing that you have to remember is definitely to do a little diagram. It will help you know which sides or angles you're looking for. All right, check this out. So a lighthouse built at sea level is 150 feet high. From its top, the angle of depression of a buoy is 25 degrees. Find the distance from the buoy to the foot of the lighthouse. So let's see what this says. So there's a lighthouse here. I don't know, like a lighthouse. There's a lighthouse right there. And this is 150 feet above ground. And then it says, from the top, the angle of depression. So from the top, there's that straight line. And then from the top here, this is the angle of depression, which is 25. And there's a buoy here in the water floating, right? I don't know how it looks. But so what they want to know is the distance from the buoy to the lighthouse, which is here, this distance right here. But then we know that this is 25, the angle of depression. Then if this is 25, then this thing here is 25 because they're alternate interior angles. We learned that at the beginning of our course of geometry. So if this is 25, then this is 25. So now we know which ones we're gonna look for. We have the opposite side, which is how tall the lighthouse is, and we have the adjacent side. So we have tangent, right? Katoa, opposite over adjacent. So let's do that. So that's tangent of the angle equals, and then opposite over adjacent, which is the one you're looking for. You are dividing again. So that's 150 divided by tangent of 25. And that is, let's see, so 150 divided by 25, and then the tangent, 321.7. 321.7. That's how far the buoy is from the lighthouse. Okay. All right. So let's check this one out. Surveyor. That's like those like you see on the, I didn't even know how is that called, but I Googled it. It's like a little it's like when they're surveying the land, it's like a little tripod and like a little camera. And there's a person here taking kind of like pictures or whatever, or distances. And that's what it is. So it's 100 meters from a bridge. So that's 100 meters here. And the bridge is right here. I don't know how to draw a bridge, but whatever. Anyways, so then the angle of elevation to the top of the bridge, oh, let's put the bridge like bigger here. So the angle of elevation, it's from here, right? The thing is looking here. The angle of elevation is this angle right here. This is 100 meters. So this is 100 meters. So the angle of elevation is what? 35 degrees. Okay. And then it says in the survey, the instrument is this piece right here is 145 meters. Okay. So you're going to have to add that. So find the height of the bridge. All right. So we're looking for this right here. Now we have to include that 145, right? All right, so let's find the side, this piece first, and then we add the 1.45. So that is, we're looking for the opposite side. We have the adjacent side, so that's tangent. So tangent of 35 equals, and then we have opposite over adjacent. So opposite is x over adjacent, which is 100. You are multiplying. So let's multiply. So that is 100 times 35 tangent equals, and then that's 70. 70. So x equals, so this thing right here, the first piece is 70. 70.0, which is 70. Let's put 70. And then we still have to add the 1.45 for the height of the piece here of the instrument, okay? Because that will give us the full size, the full height of the bridge. So that's 71.45. That is your answer. What meters? Right? A lot of these you gotta remember to put the unit, right? Because this is, so we're talking about feet here. Because then it just looks like you're talking about something specific, right? The units. All right, so that's pretty much what, this is like a combination, combined one. Sorry about the drawing, that was really funny looking. Anyway, so let's move on to another one. Let's do one more. All right, so a plane rose from takeoff and flew at an angle. So the plane is right here and it goes here with this angle of 11 degrees with the ground. It's making that with the ground. When it reached at an altitude of 500 feet, that's 500 feet here, what is the horizontal distance that the plane had flown? So from here to here, that's what you're looking for. So the plane went this way, but they want to know the horizontal distance. So actually from this point, the starting point, it went this way, right? Horizontally. So like going this way, right? It's the same distance. So that is So that's opposite over adjacent. So that's tangent of 11 equals, and then opposite, which is 500 over x. And then you are dividing here. So let's divide. That is 500 divided by 11, and then tangent equals 2,572 what? Feet. So that's 2,572 feet. That's how far it went from the starting point horizontal distance. All right, let's do one more and that's it. As viewed from a cliff 360 meters above sea level, the angle of depression of a ship is 28 degrees. How far is the ship from the shore? All right, so as viewed from the cliff above sea level, so that's the sea level is 360 meters, right, above sea level. The angle of depression, which is this one, is what? 28 degrees, which makes this one also 28 degrees because they're alternate interior angles. How far is the ship from the shore? So like right here to there. How far is this? Okay. So again, we're using tangent. So that's tangent of 28 equals opposite over adjacent. So that's 360 over adjacent. You are dividing here. So let's divide. 360 divided by 28 tangent. And that's 677 what? Meters. That's how far the ship is from the shore of the cliff right here. All right, so that's it. I hope this helps.